All right, in this video, we're going to be discussing and or reviewing lines. This is a very, very important topic, even though some of you have seen lines before and are familiar with them. This is very important because if you're taking calculus next semester or soon in the future, lines are a central theme of calculus. Okay, lines. The theme of calculus says that wouldn't it be great if every graph behaved like a line? And in fact, they can use lines to sort of approximate the rates of change of certain graphs. So this is important. You definitely want to make sure before you take any calculation, you want to make sure everything, you're sure of everything in this talk, which is not going to be too hard. Hopefully you've seen this before. One of the axioms of Euclidean geometry says that there exists a unique line passing through any two distinct points on the plane. And I mean, I think that's pretty self-evident, right? If you take any 2 points, you should be able to draw a line connecting them. But that's an axiom of Euclidean geometry. And the lines are graphs of a certain, well, we'll talk about functions later, but in a line, there's a relationship between x and y in which that the rate of change of y with respect to x is always constant. And that rate of change is what we call the slope. And it's just defined to be the change in y divided by the change in x. If you take any 2 points on a line, x1, y1, x2, y2, this quotient is always going to be the same. It doesn't matter which 2 points you have. Okay, you always get the same constant for that line. And some of you might be learn this as rise over run, or delta y divided by delta x. It's all the same thing. You could also switch these around and have y1 minus y2 divided by x1 minus x2. It's the same thing, as long as you're consistent. A couple of degenerate cases is if the x coordinates are the same, the slope is undefined. Remember, we can't divide by 0. So either say the slope is undefined, and when you have 2 points on the same line that have the same x coordinate, then that line has to be vertical. Conversely, if the y coordinates are the same, well, now in this case, the numerator will be 0. You'll have 0 over x2 minus x1. And that's 0, and then that means the slope is 0, so the line is going to be horizontal. Now, there's a big difference between having a slope existing and the slope being 0 and the slope being undefined. Okay, it's one thing because everyone agrees that there's a difference between a vertical line and a horizontal line. Okay, so when some people say, oh, the line has no slope, well, that could mean two things. It could mean the slope is undefined, or the slope is 0 equal to 0. So yeah, I want to be a little more specific. You don't want to say the line has no slope. Okay, we see it's either 0 or undefined. The slope represents the average rate of change of y with respect to x. Okay, and this is going to, in fact, with lines, this is the only case where if you take any 2 points on the graph, this quotient is always constant. So that represents the average rate of change of y with respect to x. The equation, going to the degenerate cases, the equation of a vertical line passing through the point x1, y1 is just going to be given by x equals x1, whatever the x coordinate is. And the equation of a horizontal line passing through this point is y equals y1. Okay, so x equals a constant always gives a vertical line. Y equals a constant always gives a horizontal line. Those are the degenerate cases. And in the more general case, so we have an equation of a line with slope m passing through x1, y1. We get this equation. Okay, and really what's going on here is we say if we have this is our slope and we set this equal to m, and we replace y2 with y and x2 with x, and we multiply both sides by x minus x1, we get this equation. And this is called the point slope form. And the important that when you see y here and x, these are variables. M, x1, and y1 are always going to be constants when you plug them in. So an equation, a point slope form, will have something like y minus 1 equals 3 times x minus 2, or something like that. Now there are two other forms of the equation of a line. We have a slope-intercept form. That's in the line y equals mx plus b. And the general form of the equation of a line is ax plus by equals c. In all these three forms can be transformed into another form just by doing a little algebra. The main thing is you always said all these forms can be written as something times x plus something times y equals a constant. So let's go with a few examples here. And in this first one, we want to find the equation of the line passing through the points -2, 3, and 2, 1. In this case, you always want to find the slope first and then go from there. Okay, so the slope in this case, m, is going to be y2 minus y1. So this will be 1 minus 3. And then there's x2, x1, so this is 2 minus -2. Okay, this is going to be 1 minus 3 is -2, 2 minus -2 is positive 4, and this reduces to -1/2. Okay, so that's the slope. This is -1/2. Now, to find the equation of the line, we can go to our point slope form and just pick one of these numbers. I'll pick this one, 2, 1, and then we'll have y minus our y coordinate equals our slope times x minus the x coordinate. Okay, so we have y minus 1 equals -1/2 times x minus 2. Then we can distribute the -1/2. And then -1/2 times -2 is +1. Okay. And we can add 1 to both sides. And so we get y equals -1/2 x plus 2. Okay. That's the slope-intercept form. And that's how most of the time I'd like you to write your equation of the line. We can check by plugging in the other point. If we plug in x equals -2, we get -1/2 times -2, that's 1. 1 plus 2 is 3. So that works. Okay. And if you wanted to write the general form of this line, you just have to add, take the -1/2 x to the other side, add 1/2 x to both sides, and you get 1/2 x plus y equals 2. So that would be the general form. Okay. All right, so these were the three forms of that line. If we could go to the next example, find the equation of the line in slope-intercept form, having slope 2/3, passing through the point -7, 1, and then ask what's the y-intercept. Okay, I'll let you pause the video if you want and work on this. All right, so in this case, m is already given. M is 2/3. Okay. And then we have our point here, so we can write y minus our y coordinate equals m times x minus our x coordinate. So we get y minus 1 equals 2/3 x minus -7. Okay, this will be y minus 1 equals 2/3 x plus 7. This is y minus 1 equals 2/3 x. All right, 2/3 times 7, that's going to be 14/3, right? 2 times 7 is 14, so we got 14/3. We're going to add 1 to both sides. Okay, and 14/3 plus 1 is 14/3 plus 3/3, so that's 17/3. So there's that. And we can see that the b is always the y-intercept. Or if you're not sure, we can just plug in x equals 0 and we get 17/3. So the y-intercept is 0, 17/3. All right. Okay, so next, we want to talk about parallel and perpendicular lines. We say two lines are parallel if the slopes are the same, and they're perpendicular if they are negative reciprocals of the other. Graphically, what that means is, of course, they intersect at right angles. Okay, so that's what perpendicular means. So the negative reciprocal. So the slopes. Hey, if you think about it, the slopes are going to have to be opposite signs, because if one line is increasing, the other is going to have to be decreasing. All right, so if we want to find a line parallel to this line, y equals negative 3x plus 9, and we want to have it so it passes through the point 6, 7, how do we do that? Well, first of all, if two lines are parallel, they have to have the same slope. So what's the slope of this line? It's already in y equals mx plus b form. What's m? It's negative 3. So m is negative 3. Our point is 6, 7. We can set up the point slope form. Y minus 7 equals negative 3 times x minus 6. Distribute the negative 3. Add 7 to both sides. And so you get y equals negative 3x. 18 plus 7 is 25. And in fact, I said find a line. There's only one line that's parallel to this line that goes through this point. Okay. Example 4. If we wanted to find a line that is perpendicular to the line y equals 1/5 x plus 1, passing through point negative 4, 3. In this case, our slope is 1/5. But if the line is perpendicular, then its slope is going to be the negative reciprocal of 1/5. So m is going to be negative 1 over 1/5. Okay, this is just negative 5. So we have y minus 3 equals negative 5 times x minus 4. And we get y minus 3 equals negative 5, x plus 4. Y minus 3 equals negative 5x minus 20. Add 3 to both sides. And I think we get y equals negative 5x minus 17. Right. Okay. Lastly, we want to, you'll probably see something like this in your homework. We want to use slopes to show that the triangle with vertices, that these vertices is a right triangle. And the way we do this is we want to look at show that the two sides of the triangle intersect at right angles. And in fact, we can do that by showing that the sides are part of a line, that are part of two lines that intersect that are in fact perpendicular. So probably easiest to draw a picture. -2, 5. This point, 1, 3 is this point, and -1, 0 is this point. Okay. And so we can see that we get a triangle here. Now it looks like the right angle is going to be here, but we really want to be certain of that. And the way we're going to do is let's find the slopes of these two line segments and see what they are. So once again, this is -2, 5, and this is the point 1, 3, and this is the point -1, 0. Okay, and let's say if we call this slope M1, this slope M2. Figure out what these slopes are. M1, the slope passing through these 2 points, well, it'd be 5 minus 3 over -2 minus 1. Well, that's going to be 2 over -3. And then M2, now let's see what this is going to be. This is going to be 3 minus 0 over 1 minus -1. Well, this will be 3 over +2. Okay, and so these are, we can see that these are indeed negative reciprocals of each other. So that means that the line passing through this point and this point are indeed perpendicular, and this is a right triangle. These intersect at right angles to each other, so this is a right triangle.